Okay, in this video, we're going to continue with section 1.8 and basic linear inequalities. So why is it that when we divide, like in this previous example, when we divide it by a -3, we change the sign? So let's talk about that. So let's start with, for example, if I give you a true statement. So if I say that 3 is less than 5, is that true? Yes, right. This is a true statement. So we want to make sure that anything that we do to this inequality remains a true statement. So for example, then if I add something to both sides of the inequalities, say I add 4, then does it remain a true statement? So is this still true? 3 plus 4 is 7, and 5 plus 4 is 9. So yes, that is still a true statement. And so addition works. So as long as I add the same thing to both sides, it remains the same. What if I subtract? So say we subtract 4 to both sides. Is this still true? 3 minus 4 is -1. Is that less than 5 minus 4, which is 1? 1 is less than 1? Yes, that is true. So it remains true. So if I add something to both sides, then the equality remains true. If I subtract something from both sides, then equality remains true. So now what if we multiply? I know 3 is less than 5. My original statement is still true. So now what if I multiply it by something? Say we multiply by 7. Is this statement still true? So 7 times 3 is 21. Is 21 less than 7 times 5, which is 35? And yes, that is still true. So multiplying both sides by a positive number remains true. Now what about multiplying by a negative? So starting with the original statement, 3 is less than 5. This is, we know, is a true statement. So now what if I multiply it by, say, -2? So I multiply both sides by -2. Is this still a true statement? Is it true? So let's see. -2 times 3 is -6. Is that less than -2 times 5, which is -10? And notice that this is actually false. So, and you can see that in the number line. Right? If I put -6 on the number line, where is -10? -10 is going to be to the left of it. And so 0 is somewhere over there. The further, remember with negative numbers, the further you are from 0, the smaller the number. So the true statement is that the true statement here is that -6 is actually greater than -10. So that means we have to flip the inequality to retain the truthness of the original statement. So original statement was that 3 is less than 5, and that's true. And notice, as long as you add something to both sides, the statement remains true. If you subtract from both sides, the statement remains true. If you multiply a positive number, our statement remains true. But once you multiply by a negative number, if you leave the sign unchanged, you have a false statement. And so in order for it to remain a true statement, we have to flip that sign, because the true statement is actually you reverse the inequality. That negative makes it, because as I explained here, the further you are from 0, actually the smaller you are. So when you multiply by a negative, what was the larger number before is going to become the smaller number. So that's why we switch the absolute value. So let's try another example. So let's solve inequality 2 times 3 minus 7t greater than or equal to 12t plus 8. So our variable here is t, and Again, we can treat it like an equation. Don't ever change the inequality though. Treating it like an equation, I just mean we can, as we stated above, we can add to both sides, subtract on both sides, divide. Last, we're dividing by a negative number. So let's start off by distributing this 2, getting rid of parentheses. So I'm going to have 6 minus 14t is greater or equal to 12t plus 8. Now we're going to get the variables on one side and everything else on the other. So I'm going to subtract the 6 from both sides. And if you're comfortable, do it all in one step, that's fine. So we're going to have negative 14t is greater or equal to 12t plus 2. 8 minus 6 is 2. And now we want to move the t over to the other side. So minus 12t minus 12t. So if you want to do this minus 12t on that first step, you can. And so here we're going to have minus 26t is greater or equal to 2. I subtracted. So here I don't change the symbol because I only subtracted the 12t. I haven't divided by anything. Now we're getting ready to divide. And so this is where anytime you're going to multiply or divide with an inequality, this is where you should be alert. Your warning signs should be going off. We're dividing by a negative, which means that we are going to change the direction of our inequality. So it was a greater than or equal to, so it's going to become a less than or equal to. And I'm going to have 26 and 26 cancel. Minus divided by minus is positive, so I have t is less than or equal to 2 over negative 26, which reduces to 1 over 13. So negative 1 over 13. So this will be our answer. So in interval notation, we can say t is in the interval. Since this is less than, we go all the way to minus infinity. So negative infinity all the way to negative 1 over 13. Parentheses or bracket. Are we including it or not including it? We are including it, so then we're going to use the bracket. And this will be our interval notation. If you need the number line to help you get there, then you would put negative 1 over 13. Again, there's no reason to put a 0 on the number line. Only put the values that show up from your inequality. Less than means we're going to shade to the left. And if I put a circle on that, is that open or closed? It does have the equals, which means t can equal to negative 1 over 13, so we fill it in. Or you can put a bracket there. Okay. So that is the gist for solving basic linear inequalities. So the next video is going to be on higher order inequalities.